There are several ongoing disputes and debates surrounding the theory of relativity. Some of the major points of contention include: 1. Einstein's theory of general relativity versus quantum mechanics. The theory of general relativity, which describes gravity and the curvature of space-time, is at odds with the theory of quantum mechanics, which explains the behavior of particles at the smallest scales. Scientists are still trying to reconcile these two theories into a single unified framework called quantum gravity. 2. The expanding universe versus steady state theory. The observation that distant galaxies are moving away from us, suggesting that the universe is expanding, is a cornerstone of the Big Bang theory. However, there have been proponents of the steady state theory, which proposes that the universe has always existed and is continually creating matter to maintain a constant density. The evidence strongly supports the expanding universe, but the debate continues among some physicists. 3. The existence of black holes. While the existence of black holes is widely accepted, some physicists still question their properties and the nature of the event horizon, the boundary beyond which nothing can escape the gravitational pull of a black hole. Alternative theories and explanations have been proposed, challenging the conventional understanding of black holes. 4. Time travel and wormholes. Einstein's theory of relativity allows for the possibility of time travel and wormholes, shortcuts through space-time. However, these concepts remain highly theoretical and debatable. Some physicists argue that the existence of wormholes and the possibility of time travel violate various laws of physics, while others explore the implications and potential mechanisms of these phenomena. It is important to note that scientific debates and disputes are a normal part of the scientific process as scientists continue to refine and expand their understanding of the universe. Finally, for AAN, increasing of mass of a moving object or shop traveling through space to HAOKN, mass due to the increase of acceleration. The environment of that space must have a core gravitation energy attraction force. For example, Earth gravity force measures 50% acceleration, attaches a 50% of attraction from the Earth's core. The core of the universe is unknown. It is speculated in Hubble expansion. More so, as the universe expands, it's viewed as a uniform of motion, that a push force is constantly pushing the galaxies away from each other. In a tactic or subtle universe, as you have read, clearly there is no change as expanse gives us, and festivities, gravity well makes no universal momentum amongst the stars. So actual gravitation, like Earth gravity force, is what allows mobility of non-attached object movement. A measurable force on different planets with different measures of gravity. Space is a vacuum with not an attraction force, but just the opposite, as a push force instead. Under such definition of an empty vacuum, there exists no positive attraction energy. The positive force of the space vacuum is a positive push force. This push force is calculated at a much greater energy amount than light speed energy. It is also constant. The slow drag of the vacuum push force is measured by the Hubble equations. And as an energy force, this vacuum energy has to measure much greater than Hubble's 42 mics per second to excel the galaxies apart in uniform motion, an activity that is not only constant, but equal to each end if a resplusiveness. Can it be described as a space energy called the dark energy, or is it a physical anomaly as the Hubble universe expanding the dark element? The fourth dimension is motion, no time, Rodney Kowecki. The fourth dimension. Relativity theory puts speed limits on all the four forces: energy, propulsion, acceleration, and even gravity. Why gravity? It was because gravity is set a line by itself and is questioned to be pi art of the four forces because it is a weak force. It is expanse that changes the definition of geodesic curvature and relativistic speed limit. Time is not part of the natural oscillation. because it is not a force of nature, but an invention of man. God is defined as an oscillation of nature. All things in nature were made by God, and no man can change that. Besides, time has no affect of Einstein's fabric of a flat space that his ship drags along with it, causing the energy mass to increase, in his analogy about the need of infinite mass. Space is three-dimensional and has no real flat terrain to travel on top of to advocate such of his affect for slow dragging. Under these circumstances, the fourth dimension is applied to the force of motion, that which without the universe would stand alone and dead in the water. So, this analogy, designed by Rodney Kowecki, embarks on a new era in physics, a day when expanse is positioned in the universe as the force that forms universal and cosmic mobility. We can certainly propose motion as a fourth dimension in a conceptual framework, but it is different from how dimensions are usually defined in physics. In the new interpretation, first dimension, length second dimension, width third dimension, height fourth dimension, motion. The idea is that an object is not fully described by where it is in space. There exist no signs or street corners in space, and it must also have a state of motion. A completely motionless universe would be fundamentally different from a universe in which everything is moving. Because a ship may travel through space in a long journey, the time is irrelevant if you don't know where you are. The distances in space are astronomical and measured in light years. The challenge is that motion is normally considered a change of position in the first three dimensions rather than an independent dimension itself. For example, moving north at 10 miles per hour and 20 miles per hour occurs along the same spatial direction, but at different rates. However, philosophically, one could argue space describes where things are, while motion describes how they exist and evolve. In that sense, motion becomes a fundamental aspect of reality alongside length, width, and height. Historically, thinkers such as Aristotle viewed motion as one of the most fundamental properties of nature. Modern mathematics usually treats motion as change within dimensions rather than a dimension itself, but there is nothing preventing a new theoretical model from exploring motion as a primary dimension-like quantity. A possible statement of this idea might be, the fourth dimension is motion, because without motion there is no change, no evolution of systems, and no observable passage of events. That is a philosophical and theoretical proposition rather than the standard scientific definition of a dimension. Yes, if you adopt the framework that motion is the fourth dimension, then you can interpret time as an effect or measurement of motion rather than as a fundamental dimension itself. In that view, length, width, and height describe where things are. Motion describes how those positions change. Time is the record or measurement of those changes. So you might state it as, time is the observation of motion occurring in the four-dimensional reality of length, width, height, and motion. Under this interpretation, if nothing moves, nothing changes. Without change, there are no events to count. Without events, time has no observable meaning. This is a philosophical model of time that has been discussed in various forms by thinkers who view time as emerging from change rather than existing as a fundamental entity. A concise version of your idea would be, time is not a dimension. Time is the measure of events produced by motion. That is a coherent conceptual framework, though it differs from the standard scientific view, where time is usually treated as a coordinate alongside spatial coordinates. In your framework, motion is fundamental and time emerges from it as a way of counting or ordering events.
Confirmed. The nanobots localized the anomaly perfectly. Even after all these years, the view from the 7th level bridge is breathtaking.
It truly is quite the spectacle.
Standing here high above the metropolis, the data behind me confirms the unprecedented growth in deep sky traffic we've seen this year. Observe the maglev loops synchronized with the hover lanes below us. The wheel housing needs to be more aerodynamic. See how the energy flow shifts here.
Yes, that should improve the lift ratio significantly.
The scale of the city is best understood through the transit layers. Observe the maglev loops synchronized with the hover lanes below us.
Hello, so glad you're here. The videos you are watching on my channel are about the universe, especially about space expansion, notably called the first cause. Why? The Big Bang event, a primeval egg that has cracked, releasing its energy and still releasing it to this day. Why? Again, expanse. The proof lays in the universe's behavior, the Big Bang us, the standard model about our universe, and its behavior illustrates a long-term release of its energy over time. How long is that time? 14 billion years.